Right, so opposed to bone formation, this video is about bone growth. So actually either getting longer or growing wider, right? Those are two ways that things can grow. There's going to be some similar processes to bone formation or ossification that was talked about in the previous lecture. So first, I want to talk about linear bone growth. This is at that epiphyseal plate that I talked about in the previous video. So and this is going to be very similar to the endochondral ossification. It is a pre-existing cartilage replacement model. So this is a different image that's showing a very similar mechanism to what I showed in the previous slides. Chondrocytes are going to form cartilage, of course, that's what they do. And then osteoblasts are going to replace this cartilage. So that's that endochondral piece. And this all happens just within this epiphyseal plate that is still present in humans throughout childhood and adolescence. When your growth plates close, this cartilage is no longer present here. So this epiphyseal plate is the site of linear bone growth. And what's happening here, this image is a lot like that previous one. We've got dividing chondrocytes. These are what are going to add length to the bone itself. Chondrocytes, of course, are not bone tissue, but they are going to add length to the bone organ, the whole bone. So this is happening by this compact bone at this over here, which is kind of over here. So this is within that epiphyseal plate right here. So dividing chondrocytes add length. Those chondrocytes, of course, produce cartilage, so they're going to be producing a bunch of collagen to add structure and matrix to that epiphyseal plate. Those chondrocytes that are older, right, they're dividing up this way, kind of pushing up, kind of like skin. Those older ones are going to start to disintegrate. When they disintegrate, they're replaced by osteoblasts. Osteoblasts are going to be dividing and pushing up this way. They themselves don't divide, but osteogenic cells are able to produce them and push them up to replace where the cartilage cells were, where the chondrocytes were, and replace the cartilage with bone. What that means is continue to lay down collagen as well as bring in, allow for the deposition of calcium phosphate. So laying down bone here. And that then this continues, right? More cartilage, more chondrocytes are dividing to add length. So the bone grows longer. This is a nice image of what this looks like in terms of what this is actually an image of an epiphyseal plate that you can see in an x-ray. So you can see if a child's growth plate is still there or if it has become closed up and become a epiphyseal line. Over here, this is showing the same thing here. Chondrocytes are dividing. This is a real picture. These older chondrocytes down here are starting to disintegrate, and osseous tissue, so the bone, is taking over down at the bottom here. That means bone has formed. One more image here, this one's from your book. What I like about this is it has kind of these zones. If these zones help you refer to these different steps, that's fine. It's the same as those steps I talked about before. So, and what I also like at this term reserve cartilage, this is the cartilage is kind of just hanging out, it's resting. And then just below that, there are cartilage that's actually dividing. So there's reserve cartilage, dividing cartilage that are going through mitosis. Then we've got them start to die and become calcified and ultimately break down and become taken over by osteoblasts. Okay, so that's linear bone growth. Second way that bones can grow is they can grow wider, right? We have to grow wider as they grow longer. This also can happen somewhat with remodeling in adulthood. So a circumference is added to the outside of the bone, going from something like this to this, increases in diameter. And bones grow when the matrix is deposited faster than it's resorbed. This is going to be what type of cell? It's going to be osteoblasts. They're the ones that are going to be producing this extra matrix on the outside. They produce collagen, a bunch of proteins, allow for calcium to come in. So appositional growth is a name for bone increases in bone diameter. And this happens when bone matrix is added to the outside. So growth occurs from the outside. That's very different than like skin, which grows from the bottom, which is more like the inside. At the same time, this medullary cavity is going to increase in size as well, because bone matrix is actually going to be removed from the middle. So let me actually go to my image of this. Here we go. So in a child, you've got, start with the size bone. Bone is deposited on the outside by osteoblasts. At the same time, bone on the inside, so surrounding that medullary cavity, is resorbed. It's removed by osteoclasts. That's going to result in not only the bone getting wider, but that medullary cavity becoming bigger. In adult, you can see that the inside matrix is completely gone. It's been removed by osteoclasts, and now the medullary cavity is quite big, and the bone is wider in diameter. So, learning outcome for this was compare and contrast interstitial, which is lengthwise, so long bone growth. Interstitial refers to within the bone itself, within the tissue. So interstitial means in the tissue. And appositional, so this is width or circumference growth. The terms for this one, I believe, were all words you had used before. So be sure to just use your general bone and anatomy and terminology when you talk about these two types of growth.